Hello students, now we are going to discuss about the buffered isotonic solution, right? So what are the isotonic solution, how the hypertonic and hypotonic it is going to have, and how we are going to measure the tonicity, right? So measurement of tonicity also we are going to discuss in this class, right? So let's say start with the class, the buffered isotonic solution. The heading is the buffered isotonic solution. So here we will understand what is the isotonic, what is hypertonic, and what is hypotonic, right? So coming to the isotonic solution, is very important. Two solution having same osmotic pressure, right? Whenever two solution, if drug solution or in the blood plasma, if they will be having same osmotic pressure across a semi permeable membrane, that will be called the isotonic, right? For example, 0.9% of sodium chloride solution is the example of isotonic solution, right? It will be having compatible with the blood plasma, right? So that's what it is called the isotonic solution. Coming to the hypertonic solution, what is hypertonic? Where the concentration of solute is greater outside the cell than inside. For example, 2% of sodium chloride solution, right? So that's what the concentration of solute, it will be greater outside of the cell, right? Whereas in the hypotonic solution, where the concentration of solute is greater inside the cell than outside. For example, 0.2% of sodium chloride solution, right? So whatever the concentration it is going to have, it is greater in the inside the cell, whereas in the hypertonic it will be outside. The greaterness of the concentration, it will be outside, right? So that's what different example it is having. For isotonic, 0.9% of sodium chloride solution, hypertonic solution 2% of sodium chloride solution, and hypotonic 0.2% of sodium chloride solution, right? So in this way you can able to remember it easily. Now coming to the another important fact, measurement of tonicity. What is the tonicity? How we are going to measure for any test substance or any test solution, or it may be any kind of drug. Okay, so there are two main method, hemolytic method and the colligative method, right? So coming to the hemolytic method, here in this method we have to take the two capillary tube A and tube B, right? Two capillary tube. In one tube we are going to fill the tube A, we are going to fill the blood plus 5 ml of 0.9% sodium chloride, which is nothing but isotonic solution. 0.9% of sodium chloride is isotonic solution, that we will take in the tube A. Whereas in the tube B, again we are going to take the blood. Here also we have taken the blood, but in the place of isotonic solution, we are going to take the 5 ml of test solution. For what? We want to know the tonicity, right? Now this test tube, it is both the capillary tube, it is ready. Now this we will subject, for both the tube are subjected for the centrifugation, or are centrifuged at high speed, right? Once it will rotate in high speed, what will happen? PCV, we are going to find it out. What is PCV? Packed cell volume is measured, right? Nothing but PPT, right? So what is the PPT it is going to form in test tube A and in test tube B, right? It depends on the tonicity, because how the thing it is going to. So what we are going to see in the result, in tube B is measured with tube A. Comparison, because in tube A isotonic solution is there, right? If tube B PCV it is same as tube A, it means it is isotonic, because in tube A isotonic solution is there, so there will be same kinds of precipitate or PCV, right? If it is more, means it is hypotonic. Why? Because what will happen in hypotonic, the concentration of solute is greater inside the cell. So if it will be greater inside the cell, what will happen? It will go outside, and the PCV it will be more. Whereas if it is less, it means it will be hypertonic, because in hypertonic case, what will happen? The concentration of solute will be greater outside of the cell, greater in outside of the cell. So if it will be greater, it will go to the inside, or that's what osmotic pressure we are considering about. So it will be less, right? So what will happen? It will indicate that the particular given sample of test solution, it is hypertonic, right? In this way we are going to measure under hemolytic method. Coming to the colligative method, right? Under colligative method we will be having four method. First one, it is the based on the molecular concentration. Second one, it is the based on freezing point data. Third one is the based on sodium chloride equivalent, that is denoted by E. Then White-Vincent method, right? So let us discuss this one. It's very important. You try to understand here. Based on the molecular concentration, means molecular weight, right? So here again we will be having two method in this, for non-ionizing substance and for ionizing, right? So for non-ionizing we will be having one formula. The formula suggests that 0.03% into gram molecular weight of the test solution. Okay, why 0.03% if it is there for non-ionizing in this molecular concentration formula? Because 0.03% it is the molecular concentration of blood plasma, right? So everything we have to consider with the blood plasma, because drug solution it is going to go with the compatible with, it should be compatible with the blood plasma, because ultimately after absorption by the any of the route of in the body, it will go in the contact with the blood, right? So that's what these formula, these values are there in the formula, right? Now for non-ionizing example, boric acid. So what is the molecular, because we are considering based on the molecular concentration. So what is the molecular weight of the boric acid? 62. So in this formula we will put 0.03 into 62. So the if you solve this one, 1.86 gram it is coming. So 1.86 gram is required for boric acid to make 100 ml isotonic solution of boric acid. Like that we will find out. For non-ionizing, again we will be having one formula. The formula is same, right? Only the thing is here we have to divide it by number of ion, right? That's what it is for ionizing. So 0.03% into gram molecular weight divided by number of ion, right? So let us clear with the example. Here 0.03 into 148. Here we have taken the sodium sulphate, right? So here 148 is the molecular concentration or molecular weight of the particular substance or test drug, right? So here number of ion, here we have to again we have to find out number of ion. So here two ion of the sodium and one sulphate. So 2 1 3. So 3 we are going to put here. If you solve this one, you will get the 1.48 gram. Okay, 1.48 gram to make 100 ml of isotonic solution for sodium sulphate, right? So this is the two things in under molecular concentration for non-ionizing and for ionizing. Coming to the second important here in the colligative method, based on freezing point data, right? So each and every solution it will be having its own freezing point. That data or that information it will help us to determine its tonicity, right? So let's take the example. Here also we will be having this formula, right? W is equal to minus 0.5 to minus A divided by B. So what is A here? A is, for example, if you take the example HCl, right? One substance it is there, HCl. What is the freezing point of HCl? It is 0.09. Okay, and the B is sodium chloride, for example. So freezing point of sodium chloride it is 0.576. So this value if you put in this formula, so W is equal to minus 0.5 to minus in bracket minus 0.09 divided by 0.576. If you solve this one, you will get 0.746 gram, right? So that will be the tonicity, right? Then coming to the third one, that is the based on sodium chloride equivalent denoted by E, right? So as we know, the sodium chloride it is already 0.9% of sodium chloride it is isotonic solution. So whatever the solution or test drug or test solution, if it is equivalent to sodium chloride, means we will be able to know that whether it is tonicity or not. If it is not equivalent, again we can compare it. Then fourth one, D method, White-Vincent method, right? So in this method again we will be having one formula, V is equal to W into E into 111.1, right? 111.1 it is the constant, E is the again the sodium chloride equivalent, and W is the weight of the drug, right? So in that volume, this V denoted by V is for the volume, right? So like that we are going to get the tonicity here also, right? So here it is the isotonic solution concept, hyper concept, and measurement of tonicity under hemolytic method and colligative method, right? So in this way you will be able to understand the theme of the particular measurement of tonicity and what is the tonicity, and you will be able to write in the effective way. Thank you.